lesson 8.1. This is finishing up task 3. All right, it says, what is the image of the graph of g of the point 1 and 1/2? So in the last function, I had determined that the x value is 5, and I was still trying to calculate the y value. So here's the easiest way to do it, is just to write it out. So this is your horizontal movement. It's moving over 4, and we started at 1, so that's how we got the 5. So we know this one has to be the correct answer, but I still want to show that 0 is the correct answer. So all I have to do is plug in 5 for x to see what g of x is. So g of x equals 2 times 1/2. I'm going to take 5 and plug it in for x, so 5 minus 4. And then that gives me 2 times 1/2. Remember, order of operations, have to do exponents first. 5 minus 4 is 1. And then anything to the first power is just itself. So 2 times 1/2, or 1/2 of 2 is 1. And then 1 minus 1 is 0. So that's how the 0 came about. All right. Then if you graph both f and g, you're going to see that your parent function, your exponential decay, your parent function here, it does have the isotope at 0. And you can see how this has moved down 1. You can see now that the graph has been shifted to the right 4. And it also is a vertical stretch of 2 and been shifted down by 1. All right, what does part of the graph of g lie below? Why does part of the graph of g lie below the x? Can't read today. All right, select all that apply. All right, so you can see why right here, this is going down below the y-axis. Why does that happen? And it's because of this shift here. So it says g is reflected over the x. That's not true. The isotope is y equals -1. That is true. The graph of f of x was translated 1 unit down. So the points of g of x are all 1 unit lower, leaving any that were lower than y equals 1, now lower than y equals 0. That is also true. All right, so that is all for task 3. If you have any questions, please let me know. Lesson 8.1, task 4. Create an exponential function from a graph. You can write the equation of an exponential function g of x equals a times b raised to the x minus h power plus k given the graph of the function, the reference points, and the isotope. All right, so you can see on this graph it has an isotope of y equals 3, and you're given 2 reference points. All right, so we're going to use those to write an equation. All right, so the first thing you can see is that x is positive because this is exponential growth. The function is going up instead of down, so we know b is greater than 1. And it also says identify the parameters. All right, k is going to come from your isotope. So since your y value, y equals 3, is your isotope, that means our k value, it's been shifted up 3 units. So k is 3. Use the first reference point and k to find a and h. All right, so remember from the last task, your reference point was h and a plus k. So you can set these equal to that. So h equals -2. That's straightforward. And then a plus k I can write, see, a plus k equals 4, my y value. All right, so we already set up here that k is 3. So we've got a plus 3 equals 4. Don't know why I wrote a 3 there. And then subtract 3, and then a is 1. All right. So it says h equals -2, a is 1, And then it says, how do you know that A is 1? Okay, well, again, we had the formula, and all we had to do is plug in the information we already knew and then solve for the unknown. So A plus K equals the 4. And then K, we knew from above, that was given as 3 because that was from the isotope. And then 4 minus 3 equals A, so A equals 1. So again, that's just pretty much what I did right here to the left already. All right, it says use the second reference point, A and K, to find B. All right, so negative 1, 5 equals 1 plus H, and then AB plus K. So it says 5 okay, right here is the second reference point, negative 1, 5. All right, so 5 equals 1 times B plus 3. If I subtract 3 from 5, I get 2. Divide by 1, it's still 2. So B is 2. All right, how are the values of A, B, H, and K related to the graph? All right, so it indicates a shift of the graph of the parent function to the left. Okay, your H value shifts you left or right, so that's going to be H. Indicates a shift of the graph up, so up or down is your K value. Indicates the base and allows one to determine the parent function. All right, so that's going to be your B. That's your growth or decay. And then indicates no vertical stretch of the parent function. So because A equals 1, that means there's no vertical stretch or compression on that function. All right, so then your equation would be 2. You could have a 1 there, but remember A is 1. You don't have to have it. It's just assumed to be there. So it's just going to be B to the X power is your parent function. And in this case, we've got a H and a K. So it's going to be 2 raised to the X plus 2 power plus 3. That is G of X. If you have any questions, please let me know. Lesson 8.1. Model depreciation with an exponential decay function. All right, this is task 5, your final task for this lesson. An exponential growth or decay function has the form f of t equals a times 1 plus or minus r raised to the t power, where a is greater than 0 is the initial amount and r is a constant percent increase or decrease for each unit increased in time t. The base, 1 plus or minus r, is the growth or decay factor, and r is the growth or decay rate. All right, so this equation is an exponential growth equation, but this is what you're going to use like in interest formulas and stuff like that. Credit cards charge you interest. Car loans charge you interest. Home mortgages, things like that. So we are starting to look at functions that are going to be used to determine real life situations. All right, so right here, if it's 1 plus your interest rate, that means it's greater than 1. It's going to be growth. It's going to be an increase, and that's going to be considered your growth. If it's a decrease, then that means you subtract r, and this number is going to be between 0 and 1. Remember, if b is between 0 and 1, then it's a decrease. That's a decay function. All right, so Delilah paid $23,000 for a car. If its value decreased 11% per year, for what whole number of years will the value V remain above $6,000? All right, write a model for the car's value, V of t equals 23,000 times 0.89 raised to the t power. All right, so this 0.89, so it says it decreased by 11%. So we know it's going to be a decay function. So you're going to take 100% and subtract 11% to get that 0.89. All right, how do you determine the initial value? The initial value of the model is the purchase price of the car, $23,000, which corresponds to time t 0. Remember, anything to the 0 power is 1. 1 times 23,000 is just $23,000. So exponent of 0 corresponds to the initial value. All right, how do you determine the growth or decay factor? Match the steps to determine the growth or decay factor to the order in which you would complete them. All right, so it says write the decay rate as a decimal, subtract the decay rate from 1, determine whether the function is decay or growth. Since the value is depreciating, the function is decay. So that would be your first step. Determine whether it's growth or decay, because you have to know whether you add or subtract that interest rate. All right, the next thing is write your interest rate as a decimal. And then finally, you're going to subtract that from 1. All right, then graph the model and answer the question. Use a calculator to graph the model along with the line V equals 6,000. All right, if you remember, the initial question says Delilah paid $23,000 if the value decreases by 11%. For what whole number of years will the value remain above 6,000? So right here they graph the function. And then they graph V of 6,000 because they want to know when it's above 6,000. Okay? How does the ordered pair indicate the answer to the question? The approximate point, 11.56 thousand, indicates that blank years, 11.5 years, the value of the car will decrease to about $6,000. So the value of the car is above $6,000 for the whole number of 11 years. All right, that's all for task 5. If you have any questions on exponential growth or decay, please let me know.